Okay, Algebra 2, this is still Unit 9 and Day 5, and we are still solving exponential equations. This is the third page of your notes. So in problem 7, our two sides could share the base 4 or the base 2. For me, it seems a little bit easier to use the base of 4, so I'm going to do that. So on the left side, I'm going to start by writing 1/16 as 1 over 4 squared. And then on the right side, I'm going to rewrite 64 as 4 to the third. And that is being raised to the power x plus 5. So then on the left side, I can rewrite again as 4 to the negative 2 power. And then on the right side, I'm going to have 4 to the 3x plus 15. Because the rule is power to a power, you multiply exponents. Now that my bases are the same, I can set my exponents equal, so I have negative 2 is equal to 3x plus 15, and subtract 15 from both sides. So I get 3x equals negative 17, and divide to get x is equal to negative 17 over 3. For problem 8, you're going to have to isolate your exponential first. So let's get rid of the 5. We have 4 times 1/2 to the x minus 3 is equal to 16. And then we're going to divide by 4. And we get 1/2 to the x minus 3 is equal to 4. So we can write both sides as a power of 2. So on the left, 1/2 is 2 to the negative 1, and that's still to the x minus 3, and on the right, the 4 is 2 squared. So I'm going to distribute my negative 1 to get negative x plus 3, and that's going to equal the exponent on the right side too. So solve for x. And x is going to equal positive 1. Alright, problem 9 is our application problem. When you hear about major earthquakes, newscasters tell you the magnitude on the Richter scale. The Richter scale, that should sound familiar. But these numbers can mislead you to make false assumptions, such as thinking that an earthquake with magnitude 8 on the Richter scale is only twice as intense as an earthquake of magnitude 4. In order to use the following formula, you have to know about log base 10. So some of you have heard about log base 10 so far, and some of you haven't. But log base 10 is called the common log. And it's so common that you don't write the base. And so when you see log x, that means log base 10 of x. And they use this logarithm in the formula. So to compare the intensity of two earthquakes, you can use the formula log of I1 over I2 is equal to M1 minus M2. So I1 over I2, this is the ratio of the earthquake's intensities. This is what you're trying to find. Are they twice as intense? Are they 10 times as intense? How much more intense are they? And M1 minus M2 is the simple difference between the earthquake's magnitudes. So the question is, how many times stronger is a magnitude 8 earthquake than a magnitude 4 earthquake? So we're going to substitute those magnitudes into our formula, and I have log of the ratio of their intensities is going to equal the difference of their magnitudes. So I have log of I1 over I2 is equal to 4. And then some people are getting stuck, but then remember that log means log base 10. So you can rewrite that as an exponential. You can write 10 as your base and 4 as your exponent, and this is equal to the ratio of the intensities. And that's what you're trying to find. You're trying to find the ratio of the intensities. So it turns out that magnitude 8 is 10,000 times more intense than magnitude 4. Okay, so remember to write your summary sentence about what you learned in today's lesson and then do the try it now problems on the next page.